Hello, everyone. I was asked by Mr. Sullivan to go over how to do ideal gas law questions. So I figured I'd indulge him and do the first problem on the ideal gas law problem sheet. Okay? Let's first take a look at the idea of gases and what ideal gas laws are and things like that. Okay? So it turns out gases, we depend on gases to live, right? We need air to breathe. Air is made up mostly of oxygen and nitrogen. Okay, so if everyone remembers from our covalent bond class, oxygen and nitrogen as gases tend to form up into O2 and N2. Okay, and those kind of look like this: two atoms together, right? We'll call these ones oxygen, and here's nitrogen. Okay. And draw them in some random directions. And air is basically a whole bunch of these two diatomic molecules, as we might call them, okay, floating around and bumping into each other. Okay, that's what gases are. There happens to be a lot more nitrogen than oxygen in the air, but they bounce around, they bump into each other, but they don't interact with each other. Okay. So when they were first studying gases, if we were in class, we'd go through a lot more of the history of all of this. But when they were studying gases, they noticed that the pressure that a gas is under, the volume the gas takes up. Okay, let's kind of quickly look at those. Let's say if I've got a can of gas, okay, pressure is determined by how much the atoms in the can are hitting the edges of the can. Okay, so if I put a lot of gas in here, okay, in this fixed size, fixed volume, it gets under pressure. That just makes sense, right? And you guys know this from spray paint cans, for example, or any can like that, a propane tank can. Although a lot of times those are liquid, but they turn to gas. But the more you pack into this fixed space, the higher the pressure, the higher it's bombarding the walls of the container. Okay. The temperature is, and if you remember a little bit about kinetic theory, the higher the temperature, the faster these things move around, right? So the faster they move around, the harder they hit the walls. So it makes sense. The higher the temperature, the greater the pressure if I'm in a confined volume. And it turns out that a lot of these things are related. So let me kind of quickly go over that. The video should have covered some of that, but let me kind of quickly go over the idea of the gas law is P V equals N R T. Now it's important to note this is called the ideal gas law. Not every gas obeys this law exactly, but it's a good way to model gases in general. Okay? So it gives us some idea about it. And what this is really saying is that pressure is related to temperature, volume is related to the amount, volume is related to temperature, temperature is related to pressure, so on and so forth. Let me go through what each of these means. P stands for pressure. V stands for volume. Okay. Pressure can have a bunch of different units. It can be, I think we deal with kilopascals in the homework, and atmospheres. It can be a bunch of different pressure types, millibars, things like that. Volume is usually liters, or some variation of liters, milliliters, so on and so forth. N is the amount of gas. Remember, when we're talking in chemistry, we're talking about amount of things. We're talking moles, so that's how many moles of gas I have. R is something called the gas constant. You notice whenever you're dealing with ideal gas laws, they give you the gas constant. The homework gives you two different values of it. The different values of the gas constant depend on the different units of pressure that are used to measure. And finally, the temperature of the gas. This, by the way, is not in Celsius, not in Fahrenheit. This is in kelvins. Okay, it's in the Kelvin scale. Which the Kelvin scale, if you remember, 0 equals absolute 0, no temperature whatsoever, and then it goes up from there. It's related to the Celsius scale. Okay, most of these problems just involve giving you 3 of these things. So this is always a known. This is always known. It's just a number. Okay, and you figure out the number based on what the constant, what the unit of your pressure was measured in. And if I have 3 of these things, I can solve for the 4th one. Okay, that's all I need. I need either the pressure, volume, amount. I need pressure, amount, temperature. Again, if I have any of those 3 things, I can figure out the 4th thing just by solving it algebraically. Quickly erase this. Okay. Let's take a look at our problem that we have. Straightforward. I have 4 moles of a gas, so N equals 4 moles. Okay. I have a pressure of 5.6 atmospheres. Pressure equals 5.6 atm. I have a volume of 12 liters. Okay. And finally, I have to look up, figure out what my R value is. So I'm using atmospheres for pressure, so I use this value of R. It is an atmosphere. See that? The way this kind of the gas constant works out, by the way, is you notice all the units, liters, atmospheres, kelvins, and moles are in the gas constant. It cancels out everything, giving you just the value you need. So we'll see in this case, this one we're looking for temperature. All the rest would cancel out and give me the unit in the temperature unit. I'll show you that in a second. 0.082. 0.0821. Okay? I'll write out everything in units in a second. Okay. So what I need to do first is, the thing I don't know, I've got all of these, so I've got 4 of the 5 that I need. I need to know what is the temperature. Well, first thing I'm going to do is I'm going to solve this algebraically for temperature. Let me just do a quick erase. Okay, I'm going to solve it for temp. I'm going to be a little verbose in my solving here, so bear with me. Let's write the original equation. P V equals N R T. What's my unknown? My unknown is temperature, so I have to get this on one side of the equal sign, everything else on the other side. How do I do that? Well, the easiest way is to multiply by the reciprocal of this value to move it over here. Let's do that out. So reciprocal is 1 over NR times PV equals nRT times 1 over nR. Okay, just multiply by the reciprocal value, get it over the other side. Same thing you do when you are solving for any unknown. Okay, I'll do the math out a little verbosely here. So what's PV times 1 over nR? Well, that's 1 times PV is going to be PV over nR. Okay, and here I'm going to go nRT over nR. Okay, I'm going to regroup this side a little bit. I'm going to make this PV over nR equals nR over nR times T. See, I just regrouped it a little bit. This here, anything over itself is 1. 1 times T is T, so this whole side equals T. And therefore I have T on one side, everything else on the other side. Let me rewrite this up here so it's a little clearer. T equals PV over nR. Great. This is the same process you do in all of these problems. You do this process. You might be solving for N. You might be solving for V. You might be solving for P, but it's the same thing. Let me erase all these. Okay. Back over here. All right, so we want to know T. We have everything else we need over here, but we're going to plug those into this to get our answer. So T equals 5.6 times 12 over 4 times 0.0821. If you guys look at the units, you'll see that the thing about the gas constant is, this is the gas constant here. You notice it's got moles, temperature in kelvins, atmospheres, and liters. Well, I've got atmospheres, liters, and moles here. They all cancel out and just leave me with kelvins for the answer here, okay? It's going to add a lot to go through all of that. So just trust me when I say that the units all cancel out to give me the unit you really want there. Let's do some quick math. This is definitely calculator math. So 4, let me clear my memory. 4 times 0.0821. Here's my denominator. 5.6 times 12 divided by, it's going to give me 204.62. So my temperature is going to be 204.6. My temperature is going to be about 204.6 Kelvin. And that's my answer. Okay? So that's how you do these type of problems. You're really just solving for the one unknown you don't have, plugging numbers in, and getting the value you want. Okay? And the units magically work out because of that gas constant. Okay? Take it easy, everyone. I will talk to you soon.